we are live. We are live. Yeah, that's it. So let me just share here the links. We're gonna do dumb vulnerable Defi the puppet. 1 second. That's connecting stuff. Oh, let me put my phone. Okay. Let me test the chat. Looks like that should be working, I guess. And let's see Twitch. My camera kind of annoy me because it's kind of freezing. Maybe let's stop freezing, but I don't know what's the cable right now. Okay, let me take the cable. Okay, that's also working here. Okay, so 1 second, I'm gonna be back soon because I'm gonna take some cable. All right, so let me try fix that camera. Gonna use that in such a way. Here. That wait. Oh, I cannot do that. Of course, I cannot do that. How am I gonna make that camera works? Okay, maybe. Okay, let me cancel here. Quality. Okay, let's go less bits. That's gonna decrease a little bit the quality. Yeah, I don't like it. Oh my goodness. Why that's so hard? Why that cannot be more simple? So that's IP. Yeah, that's for USB. So you see now we don't get delays. But how I'm gonna make maybe like that. Okay, I think that's good, right? So we just need to flip, rotate as clockwise 9 degree. No, it should be, yeah, play. All right. So the camera here is good, but because I don't have normally too much light here, that got problem. Okay, I think we are now fine to go. The camera is good. It's not perfect position, but should be enough. So That's the, let me share the screen. I just forgot to share the link. I mean, okay, so we're gonna crack the puppet. The puppet. So there is a lending pool where users can borrow the token. To do so, they first need to deposit twice the borrow amount in Ethereum as a collateral. The pool currently has 100,000 TVTs in liquidity. And so it means I can borrow all that amount. That is DVT market open in the old Uniswap V1 exchange currently with 10 Ethereum and 10 DVT in liquidity. So they are 10 Ethereum. Maybe I need to take that, right? Pass the challenge by saving all tokens from the lending pool, then depositing them into the designated recovery account. You start with it 25 Ethereum and 1000 DVTs in balance. Okay, I need to save save all tokens from the lending pool. So I need to save that token. So it means something that 1 Ethereum is equal 1 DVT, right? So I should be having 100. No, I should be having 10,000 Ethereum to be able to take all the DVTs. So they should have some protocol problems there, right? So let's go to Puppet. I don't know why it's like kind of freezing. So let's take him down, open again. Okay, let's close the others. Puppet. So that's our tests. And then here in the puppets, we have the contracts. So we have two interfaces here for the factory, for the exchange. So the factory, Uniswap, they have create exchange template. Template from the exchange, the get exchange, token ID initialize factory. That's external. That can be a problem already. Maybe I can re-initialize. So here in exchange, we have some events. We have added liquidity. We have allowance, approve, balance, Ethereum swaps, transfers. I remember some bugs where we can manipulate the values in swaps. Setup symbol here, minimum deadline. And so, okay, that's gonna be, we're gonna need to study a lot contracts here to understand, I guess. Also, they only have the interfaces here. What a little strange for me. But I go to, let's see the test. So the test has the pool and the interfaces. And here we have the total reserve 10 and 10 in one swap. My balance. The player, wait, yeah, the balance as token, the balance as Ethereum in the pool. So I need to save the pool, all that amounts. Here they define, it's possible to define an interface now. Oh, I see what he's doing. So he's taking a build one swap folder with JSON because there inside it has the deploy code. Oh, it means the bytecode for this exchange. Really, you're gonna need to see that? Okay, let's see the build folder. So that's an exchange, right? So they have the ABI, okay, normal. And here we have the bytecode. So the bytecode here, if you want to understand that, we need to copy and go to EVM code. Now, I think they have better tools for do that. We're gonna figure out later. But for now, just let's see why they don't copy. Ah, they do copy it a lot. Okay. And you can see here, I'm checking if they have deploy in the beginning. I don't think so. Maybe that's the jump. Let's see, let's run. And then we're gonna step, I think it's step into, right? Yeah, jump, doing some stuff, putting, okay, code copy here, it's putting all in memory. And then you're gonna return. So the return here is gonna be the deploy of the contract. So I need to copy all that stuff. What's the easy way? I don't know. Okay, so let's copy, because they're gonna return here. It gets finalized. So we need to paste again, run again. Now we have the data. So you see he's checking for the call data. They put something in memory, put something in the stack, and put to memory. Keep pushing. Okay, he's building something there. And then you're gonna check for equality into the stack. If that's 0, push, jump, push, check again. So that's for functions, I guess. So it's looking for functions, and for example, that's a function. And if we go for 4 byte, or you can use cast. Maybe cast is better. Cast 4 byte. You see that call remove liquidity. So here you are inside the code. I'm gonna assume it's correct for now. Maybe they have a bug here. We need to decode that to figure out. Another thing we can do, like we can check the bytecode. It already exists in a block explorer. So that's gonna confirm us if they have some bugs here. But okay, so they deploy the contract. Also deploy the factory, the exchange that will be used as the factory template. Deploy the factory passing the templates. And then we have create exchanges. So create exchanges, accept the token, and then exchange is gonna be created. Then they're gonna deploy the lending pool, where they expect the exchange and the puppet. Okay, so so something that can happen is inside that JSON, they could have some function with admin privileges, but that was not defined in the ABI, and we could freely call that. So that maybe can be already a thing. We don't know, but let's keep that in mind. Maybe I'm gonna type here. So if the bytecode has a different new admin function that was not listed in the ABI, can be an issue. Need to investigate and compare if the bytecode has something. I think today they already has something. For example, let's go for Claude. Oh my goodness, no, I don't want to open the one. Let's go for Claude. And here we should be have a new stuff, right? And I can ask like, there are some tools that take bytecode, EVM, solidity, and dissembler, showing all functions, checking against some 4-byte website, for example. But let's see if that already exists. Let's continue. So, okay, so we have the lending pool. Then we're gonna add some initial token in liquidity. So first we need to approve, allow an exchange take stuff. That's the amount. Then you're gonna call add liquidity, passing the Ethereum as reserve, and the minimum liquidity is 0. And here the token and the deadline. I don't remember the deadline it means here. I think it's the deadline because they're gonna do a swap. No, they don't do a swap here. Yeah, I need to remember. We can check. And okay, let's see. He found the decompile, paste bytecode decompile functions. Okay, so let's try that. That handout I use in the past. EVMD's light assembler. That's for Etherscan. That's another databases. Okay, that looks cool too. But just for signature. I want something more like, okay, let's paste these if they can find or decompile. And another thing we can do is go Uniswap v1 GitHub. So we can take from sources. Let's see how you can see bytecode here too. So the exchange has this bytecode. It's already a little different, I think, because of constructor. I don't know, but that's something we can need to check against. Take a while click here to copy the link, which can be used later. All right, understand. So let's let him take that. So probably it's the close what you described. Round assembly. Okay, let's install these. I don't know if that's the, yeah. That's gonna take some time, you know. Rust, slow. Let's see some documentation just to understand what they do. So they're gonna do the assemblies, control flow graph generation. So that's good. So we're gonna do the compilation, storage dumping, dude, good. Maybe that should be enough for us. Cool stuff. So what? Bifrost? I don't know Bifrost. What they do? Oh, I think I remember reading something about in the past. What's the beef? Yeah, I don't know. I don't remember what it is. But we don't care, right? We don't need to care about. So academic citations. Yeah. Okay. Oh, nice. So that website did for us. He can also find some similar contracts. Okay, so they took the data informations, but here in the split, nothing. Okay, so we can take you and to be logged. Okay, really? To compiled. So I need to be logged, but they said they also, oh, they didn't. Yeah, let's go as terminal. So file to compile the contracts can find to reuse caused by parsing crates time core. Feature caused by is required 2024. Cargo fit call 24, but if it's not aligned in the version cargo, so we need to upgrade. So consider try a new version of cargo. Yeah, my cargo should be very, very old. And we are in 2026. Okay, we can run cargo fix edition. Okay, so I don't want to do that. Okay, maybe we need to do why did it install? Okay, let's take that. Probably need to update my cargo. Yeah, I don't remember what's the current version I'm running. If that don't bring any enough version, try nightly. How check current install via the dedicated installer with handles these. Oh, okay. Yeah, I think that's the right approach. They rebranded CLI to Bifrost in the newer versions. Okay. Okay, so let's try go the script. Installation completed. I need to open new terminal, right? Bifrost. Okay, nice. They're gonna clone from the GitHub. So they're gonna build, right? And the build probably gonna take some time. And maybe you're gonna freeze my stuff. I'm dropping some frames. I'm dropping some frames. The Okay, I'm connecting the cable and I think it's stable. I think. Right. So let's continue that. So here we do the approve, they added the liquidity, and we called transfer, token transfer to player, right, with initial, and also to lending pool with initial. Here has some validations, and here we have our way to crack stuff, and here the function to calculate Uniswap prices. So that's gonna be very fun. We need to take so how that calculate token to Ethereum in at input price. So token sold, how much tokens has in the reserve, how much Ethereum. They do good calculation to tell us what's the price. They took that plus 997. Why? Then reserve, then divide by and multiply by. That's very weird. Why? 3? Fees? Fees? I don't know. I think it's the fee, right? Should be 0.3%. So if we take 1,000, 3% should be, I don't know, it's not working. Oh my goodness. That's gonna take so much space. That's something I hate for Rust, and also make my machine slow. Right, so basically single transactions. Okay, so let's check if that's solved. So this player should be basically one transaction. All tokens on the lending pool was deposited and the recovery. So token 0 and here. Okay. So we need to study the puppet pool. They have a ring trust guard. They have a deposit factor by 2. They have the Uniswap pair. And we have token and deposits. So who has deposits? How much deposit they have? They define here the Uniswap pair address in the constructor. So if you go back here, we can see they call the exchange. Yeah, makes sense. The V1 version. You deploy I'm gonna stop. Let's go. I'm gonna do that offline, the download. Then we can do the checking. Okay, now it got freezed. Okay, still a little slow. Let's close Telegram. And these two. Yeah, it's OBS. Take a lot of process. Right. So allowing borrowing tokens by first depositing 2 times their value in Ethereum. So here the amounts and then the recipient who are gonna receive, right? They cannot re-entrance. So they can calculate the deposit requirements. That should be simple, right? Calculate. Oh, they have an oracle as price. So that's something we can manipulate, I think. Right? So, so the amount is here, they multiply by these. And for example, if that's 0, that's a multiplication, right? So if that's 0, all that's gonna be 0. And that divided by this is gonna be 0 and 2. So the amount required is gonna be 0. To make that be 0, I just need to have these as 0 too. If I have balance as 0, that I don't think it's possible because I don't have control about this. No, I kind of have. If I swap, that's this Ethereum, right? They should have a lot of Ethereum there, if I'm not mistaken. And then divide by the token balance of Uniswap. So how much the Uniswap pair has token, and for example, if that's 1 Ethereum here, that should be 1 token here. That if it's 10 Ethereum, that should be 10 stuff. All right, so probably the thing gonna happen here. So let's continue to see. So they check the deposit required. If the value is less than the required, should be not enough collateral. If the value is greater than the deposit, then they're gonna do unchecked send value. So unchecked means I can overflow here because we have a subtraction, right? So subtraction work for us. I want to have a lot of value sent to me, right? Wait. Okay, they take my value I send, less the deposit required, and send, but what? Oh, in case I send too much. So let's say I send too much, they're gonna give me back. But if I can overflow or underflow here, they're gonna send me a lot money. If they can send a lot of money to me, I can, how gonna break that? So here we have another unchecked. That means now the guy have all that stuff deposit. And again, that can be overflowed because he's summing up. I cannot underflow here, but I can overflow. If I go to the higher number possible here, they're gonna be 0. I don't see advantages for that, but okay. Fails if the pool does not have enough tokens in liquidity. Okay, see the tokens transfer failed. And that's strange, right? Because I can borrow but never give back, right? So that's a weird pool. So it's basically swapping. Allow borrowing tokens by first depositing 2 times. Because they need to deposit 2 times the value. So the thing is, I have some Ethereum I can spend. That's 25. Here it's 1 by 1, 1A1. So with my tokens and Ethereum, can I change the relationship of the reserves? I should be able to do. So what I need to do, what I need to do to change that? I need to swap. Maybe I need to draw that stuff. Yeah, I'm gonna need to draw. Also, I'm gonna need to see the code for in Viper. Oh, the view one it was in Viper. True. I just forgot about that. That's why the thing is in bytecode, right? That's too little. Okay, so what do we have here? We have some gets, we have some balances, tokens, and so on. We have some name on symbols. And we will add liquidity. So deposited in tokens and the current duration to minimum unit tokens, to mint unit tokens. Mint liquidity does nothing when the total unit supply is 0. Minimum number of units sender will mint if the total supply is greater than 0. Maximum number of tokens deposits max amount, etc. I'm a little not focused right now, thinking another stuff because I need to get out in 20 minutes. But yeah, that's payable. Viper is so cool, right? So beautiful. Like Python. They check the deadline if they greater than timestamp and etc. They check the total liquidity. So here they do the calculations. Reserve plus 1. Yeah, I'm too out of track here. So I can call some functions to see values. I can swap. I can convert Ethereum to tokens here. That's the minimum tokens I want to receive. Yeah. And that's the deadline. That it's Ethereum to token transfer input. Convert Ethereum to tokens and transfer tokens to recipients. What's the difference here? Convert Ethereum to tokens. It's not the same. Let's call it the same function. Here just only checking is recipients different from self. That's outputs. I never really understand the input output naming in the functions. And that's private. That's output again, convert Ethereum to tokens. I think output you need to do the amount of tokens. Yeah, I don't remember. Anyways, having tokens to Ethereum here. Swap outputs, transfer, input, swap, etc. etc. I will have a token to exchange. Convert tokens to tokens. Self tokens to exchange address token. All trades through contract that were not deployed from the same factory. Strange. Approved. Public price function for token to Ethereum trade with exact output. I'm gonna call gets that do the calculation for reserves. So so here pricing function for converting between Ethereum and tokens. Output amount of Ethereum or tokens being bought. It's output amount. Input reserve amount in Ethereum or tokens. Input type in exchange reserves. Yeah, that's just a formula, right? Nominator, denominator, and dividing plus 1. So that's input reserve. Let's say that's 1 plus 1. It's not plus, it's multiply by 1000. Then we get the numerator. And then we have output, last output amount. I think that's fees, right? It's a weird way to do fees. So let's go to Scholar Draw. So in Scholar Draw, let's refresh how V1 works. V1 don't have the relationship of K. They have. Let's go to add the liquidity. So here we get the self-balance less how much was added. It means that that's something cool. It means that already in the function, the max value was added to the balance. So they want to know the reserve before the value added. So we have the token reserve, and that should be 10 and 10. That should be 10 and 10. Then we have, wait a second. It's like I got a notification. Right. So we have the token amount. That's the value plus the token reserve divided by the Ethereum reserve. So let's plus 1. I don't know why they have plus 1. So let's put that in this Scholar Draw to us be able to reasoning about, right? So I have 10 Ethereum reserve. That should be like that, right? And we have the message value, how much was added. So let's say we're gonna add 1. So if I'm adding 1 Ethereum to these, they need to mint. I think they're gonna mint some tokens, right? Some unit tokens. What the fuck is my? It's another. Yeah, because here the minimum liquidity was 0. Whether that was called. And the total supply should be 0 too. So the first time they're gonna get here. Right? The total supply should be initial liquidity, etc, etc, etc. Second time, if you want to add, you see the amount you might minted, because that should be a token. You have a balances. Yeah, UniV1 naming symbol. Okay. So the calculation is okay, here you can burn a unit tokens to withdraw Ethereum and the current duration. Right. So let's finish the thing here. We're gonna multiply by the token reserve. The token reserve, it's the token DVT. So that should be also this. And he's multiplying by this and divided by this plus 1. So I guess the order here for multiplication is that plus that multiplied by that divided by that, and the result sum up 1. We can check that in chisel, right? So we can go like what? Oh shit! 1, 10 divided by 10. Maybe I need to create variables. I could go ether too, right? Plus 1. All right. Let's go now doing like that. Yeah, see, they did in the exactly same way. If we did like that, it should have a problem because that's gonna be greater than this, and they're gonna have a problem for division. So this should be the way what they do stuff. And then he said how much decimal is. We can see the difference, right? So by the way, why I did just not put like that, right? Oh, now it's correct. Yeah, the multiplication there was not right. So they have a plus 1 because I'm adding 1. That should be 11, right? So something's all right. Okay, so that by that. Okay, fair. No, that's not right. Because 1 per 10 should be that. Okay, 1 ether plus 10 ether and 10 ether. Because of the zeros, right? Divide by 10 ether. Plus 1. String, that's like one way. That's the string part. But okay. Oh, here they don't have +1. What am I thinking about? Oh, that's for remove. Yeah, the add, they have +1. That should be the token amount added. So here they say to go in way. Value added. One something +1 token amount. And the liquidity minted should be the total liquidity divided by Ethereum reserve. So the total liquidity here is the 100,000. And my value here should be this divided by this. So you got 10,000 as liquidity minted. And that's why, because when you're gonna take back, that's gonna represent 1 or 10% of the liquidity. Yeah, I need to go. 9 minutes. Unfortunately, I should be starting soon. But yeah, so that's the refresh. I refresh a little bit here, and you see the balances for the unit token for the sender are gonna be increased, and the total supply also gonna be the total liquidity gonna be increased. The total supply is gonna be the total liquidity plus the minted. It's funny that total liquidity came from supply, and supply was defined here, not here. Here's a subtract amount too. That don't look right. Yeah, so here's the first supply, initial liquidity, and they take as unity last number from balance. So the first balance, wait, so the first balance should be 0. No, the self balance is the unit token, right? Yeah, I think the first time they pass, yeah, it's Ethereum, should be 100,000, 0, and initial token reserve. And they check it here, they do the checks. The checks check for get the token to Ethereum input price 1, and that should be equal for the based on the formula. And if they call the deposit require asking for 1, it should be asking double. And here also for the balance double. What I want to know is so here we have Ether in reserve. Here they check pool initial token. Here, initial Uniswap token. So that's a Uniswap token. Oh, 10. the name is it's confusing, right? Because here they have a 10 DVT in liquidity and 10 Ethereum. 10 in DVT, 10 in Ethereum. Okay. Then I'm gonna check the price, get token to Ethereum, input price. So I think it's 1 Ethereum. Get token. I think it's that functions because they don't write get on this. Oh no, they're here. So that should be token to input price, that one. So they're gonna take the DVT token. That's a reserve. And they're gonna so you see I can modify the token reserve just sending tokens to this. And here they're gonna call get input price, passing the reserve, it taking the balance, that's Ethereum, to tell me how much Ethereum I can get if I swap, right? Because here we have two things. We have the swap and we have the unit token. That's the represent how I can take out the pool. And the way where we can take the money is make a reserve bigger than we really have. So we have here a pool with 2 tokens. That should be Ethereum. That should be DVT token. So let's say we have here these amounts. That represent 10 and 10. Who add liquidity gonna have imbalance some representative of these values. So we have a unit token. So the user that added the 2 gonna have, let's say 1 unit token. And now we have a total supply of, I don't remember how they use the total supply to be defined. It's the supply, it's the, I think I need to put that in the IDE, right? Stuff gonna be changing functions here, adding. So the first initial liquidity is the self-balance. In the self-balancing exchange, calling adding, you see here is the 10,000 Ethereum. So they have 10,000 Ethereum and they have 10,000 sorry, 10 Ethereum and 10 something. So the initial liquidity total supply is just the balance first time. It's freezing. I don't know what's happening. Missão Moisés. Hey, hey. What's up? So here, the total supply should be 10. What? 10 Ethereum, the total supply. And when we add something, they're also gonna give the balance as 10 for who added. So here, people gonna have 10. That should be 10 like that, right? Based in Ethereum. I'm fine too. I'm late, to be honest. I need to get out to go with my wife, like in Stone. I'm gonna need to finish that later, probably tomorrow. But the idea is that when now I add more, I am gonna have some unit tokens, and I need to change the relationship between the two to I be able to make like the DVT the price is very cheap, and then I can borrow all the money. Yes, so that's gonna be the trick. That's for now. It's already 1 hour. Damn, we did nothing 1 hour. Just fly by us. But yeah, I think I'm gonna copy that. You see, it's freezing. I don't know why, and I'm kind of lost too. Okay, let's go new one file. Yeah, they don't let create a new file here. So what it is, but yeah. So tomorrow, probably tomorrow. Oh, and because I don't remember for the V1 version, it's so old, and how we gonna crack that. So thank you, Moises. If you want to see the others in the series, it's already also in the YouTube too, and also a good way to practice some English listening. See ya, and thank you.